Hi everyone, I'm going to be going over lipid identifications today, talking about what they look like, their structures, and their functions. Let's get started. So first off is fatty acids. On your left will be palmitic acid. It has 16 carbons. These are usually long hydrocarbon chains with an even number of carbons attached with an end functional group of a carboxylic. Some of these do contain double bonds that would make it an unsaturated fatty acid, and if there is multiple double bonds, then it'd be a polyunsaturated fatty acid. Saturated fatty acids have higher melting temperatures and they are more flexible in membranes, while our unsaturated and polyunsaturated have lower melting points and they're a lot more rigid just because of their double bonds. They don't have that movement in space like a saturated fatty acid would. Next, we'll move on to acylglycerols. This is a glycerol backbone, which is a three-carbon chain with alcohols on each group. When a fatty acid is combined with that alcohol, you create an ester that you can see here on each one. You need to make sure you have your proper stereochemistry here. As you can see, it is S, and that is how you make acylglycerol, also known as a triglyceride. Move now on to glycerophospholipid. So glycerophospholipid is a glycero 3 phosphate. You'll have two fatty acids attached, and then you'll have a polar group attached to that phosphate group that gives it a polar head. As you can see here, serine is attached, but you can also have ethynylamine or water or choline that could go there, and you'll see different functional groups. These are very important in membranes as it gives you that polar head and that unpolar tail. So you have those two different components, and this will build your lipid bilayer in your cell membrane. Then we move on to sphingolipids. They have a sphingosine backbone. As you can see, you have a sphingosine attached with a polar head, and then you have a fatty acid with an amide linkage, so something a little different. That polar head can again be choline, ethynylamine, water, anything that's really polar. And then you'll have your fatty acid in your sphingosine. These are really important in nerve cells, especially building the myelin sheath. They're really protective, and they help build that bilayer. Steroids are next. These are building blocks of cholesterol and hormones in your body. They have a very standard shape of that 3-hexagon ring with then a pentagon attached to that. They are a major component of animal cell membranes. They increase the transition temperature and fluidity of the membrane. They're also really important in messaging within the body. So now I'll move on to fatty vitamins. These are stored in your adipose tissue in your body. So vitamin A helps with your eyes, vitamin D and E help support your immune system, and vitamin K helps with blood clotting. Unlike water-soluble vitamins, these are a lot harder to get out from the adipose tissue and into your blood system. So they need like a raft to get them there. And then prostaglandins are a derivative of arachidonic acid. You can see at the top, you have arachidonic acid, and through a series of steps, it becomes a prostaglandin. So these are chemical messengers in the pain and fever response. So when you take like Advil or Tylenol, it stops that, and so you don't really feel that pain or have that fever anymore.